how to make that content be reproduced outside of the studio in a live scenario as well. So how you control what we're saying, how you control the quality of the audio chain from microphone all the way to including cables. And we had this conversation before, right? Like how to make internally in the company, we talk sometimes about when you mix the song in the studio and then perhaps the mixing engineer in the studio is not the same as the mixing engineer on live, but supposedly it should be, right? When you record your material and sell to the people, I think ideally you want to sound the same as what you are selling, right? So I think that we can also help to bridge that gap as well. And also it's good for you to attend this kind of trainings to know all the factors involved in live sound. So good job, do it. I want to go to the house. Right? Yeah, you can. It's a dream. Yeah. We check it. Yeah, but why not? Yeah, let's. Yeah, but so I cannot ask you what is your career because you already have a career, right? Why you are here? No, but kidding เราเล่น ไม่ต้องตามแล้วใช่ไหมครับแต่เป็นอาจารย์อยู่แล้วใช่ไหมครับโอเค And at this moment what do you like? Because everyone has to perform, everyone has to play instruments here, right? Okay, very good. First. ผู้หญิงครับ I think also at least if we give you some, so for those that will go outside later on to work and, you know, in the real world, at least, again, we don't possess the absolute truth. We are giving you some basic clues to build the foundation of how you should eventually think when we deploy some systems. So if you can use that one as your base for the future, I think things will change in the near 5-10 years in Thailand, because still we see a lot of funny things. Right? Should we keep waiting? Or we start? It was 2-3 gentlemen, right? Okay. กินกาแฟอยู่ไม่เป็นไรกำลังมาโอเคครับผม
Okay. So in the morning we discussed some of the basics of point sources and linaries. Now we're just going to go over some subwoofer concepts, and then after that we'll do looking at it in the software and seeing how it can help. I'll start by saying that in the studio and in live sound, the goal is kind of similar, but maybe taken to extremes. So in a studio we want to have good impact and good alignment between our studio monitors and subwoofer. In live sound, we take it to the extreme. Like, if you don't have impact, then you've messed it up. If you in the studio, we'll say you want a kind of neutral tuning to your sound system, maybe a very slow, like small rise on the low frequency. In live sound, you take it to the extreme. You have to have that impact. You have to have the dynamics. Otherwise, people don't think it's a good show. So subwoofers are a very important part in achieving that impact and achieving that contour. And basically, we're going to go through a few different kinds of deployments, which can give. We're not going to say which is the best one, because there's no best deployment. It's just, if you see this, if you have this problem, this is how to fix it, essentially.
Also, what Simon mentioned is related with how the ear works. So usually our ear response is not linear. We don't listen at the same, or we don't perceive all the frequencies at the same intensity, let's say. So we are more sensitive at 1K, 1 to 3K. So we are less sensitive at very high frequencies. We are less sensitive at very low frequencies. So when we deploy some systems for live sound, we have to compensate with additional low frequency content, usually in the range of 15 dBs up more than what you get on the mid and high frequencies.
Okay, so the first and the easiest deployment of of subwoofers is just having one box. So in this scenario, it could be this one in the middle. And if you look down on the top of this box, then this is the coverage pattern that you're going to get. So it goes out pretty much 360 degrees, omnidirectional, all around the subwoofer. And we could maybe get up and have a listen to it.
And above too. So now we'll have the dispersion of this will be like half a sphere. So it will be, take an orange, cut it in half, and this is how the sound will travel out of this thing, okay? You can come and walk around, and you can feel it's pretty much the same. Change the preset, right? How difficult?
crossovers โอเคอันนี้คือฝั่งด้านหน้าฝั่งด้านหลังใกล้เคียงกันเนาะคืออันนี้หน้าข้างหน้าอยู่ฝั่งนี้หลังอยู่ฝั่งนี้คืออาจจะแตกต่างกันนิดนึงแต่หลักๆก็ออกรอบตัว Yeah, I was going to do. This morning, we said that if something is 180 degrees out of phase, it will cancel. So let's try it with the subwoofer. So I'm going to have the bottom one as normal polarity and the top one flip polarity. So very easy to do. So คือนี่จะลองให้ฟังว่าจับขับคู่ตัวหนึ่งก็จะเป็นยังไงนะครับอันนี้คือคู่ตรงทั้งคู่นะครับคือใช้ปกติและอันนี้ขับคู่ตัวหนึ่งเสียงหายไหมThis is a never do it in live sound.
Inside of a room, you have this effect in certain parts of the room just because of a room mode. So that the room will do it by itself because of the way the boundaries are set.
Okay. Where did I put the clicker? Here. Oh. Okay. So we're going to go to the next type of subwoofer deployment is a cardioid deployment. So cardioid is trying to cancel the sound at the back and trying to increase the sound at the front. Very similar to a cardioid microphone. So this mic is cardioid. It takes sound at the front and doesn't take sound at the back.
Here you cannot hear pretty much anything, but if I start to twist, it's coming, and then it's disappearing. So this is a cardio microphone, right? So you can see. It will be the same, but in speakers.
สำหรับ cardioid ก็ do in English first, sorry. So for cardioid, there's a few different types of deployment, like inverse stack or end fire. Basically all trying to do the same thing, which is cancel at the back. The good thing about end fire, for example, is having a very good impulse response. So you have two sound waves which are delayed, just like we have with the main speaker and the delay speaker, and they travel forward together. For inverse stack or front back, you're going to have two waves which are trying to cancel each other actively at the back, which means at the front the impulse response is not so good. It's going to be two waves traveling towards you. So front, the good thing is very good cancellation at the back, but slightly smeared time domain response in the front. So in Thai we do ก็คือ cardioid ก็จะมีหลักๆก็ประมาณ3แบบที่จะเห็นในตลาดทั่วไปนะครับมี end fire ที่เป็นลำโพง2ตัวแบบนี้ใกล้เคียงกับ main กับ delay คือก็จะมีคลื่นเสียงเป็นคลื่นเดียวกันทั้งคู่เดินไปข้างหน้าแล้วหลังตู้ก็จะหักหลังกันสำหรับ front back ก็เหมือนจะขับขั้วตัวหนึ่งแล้วหันหลังตัวหนึ่งอันนั้นคือมันจะเป็น2คลื่นหักหลังนั้นหลังตู้ดีมากแต่หน้าตู้ก็จะมี2คลื่นแล้วซึ่งพวก impulse attack ของมันสู้ end fire ไม่ได้สู้แบบตู้ใบเดียวไม่ได้แต่หักหลังนั้นหลังดูดีมากก็อยู่ที่ว่าเราจะเลือกอะไรนะครับเราน่าจะทำ end fire ที่นี่ได้สายน่าจะพอเดี๋ยวลองทำไว้ก่อน
The question is, when do you use one and when do you use another one? Then the answer is space, and it depends. Personally, Personally, if I can avoid it to do anything, I just put all in the front and boom, that's it. Easy. But if the artist is gonna complain on the stage, they say, "Oh, we want it clean," and as you can imagine, when you have a lot of subwoofers, what you have in the front, you will have in the back too. So you have a lot of energy going to the front, but also you have a lot of energy going to the back. That can cause some problems, some feedback. So if it's requested, this configuration sounds better, as Simon said, than this one. And usually the manufacturer will give you a preset to just press a button, and the sound will, the processing on the speakers that are in the front will be applied. So we were explaining subwoofers, so I'll summarize. So basically we say subwoofers, it's like a, subwoofer is like a point source, basically goes all directions. Typically every subwoofer, except these ones are cardio in the box, which is a special thing. So the sound will travel, will radiate X, Y, and also Z. Same. So what we did this example is let the people walk around, so sound is the same. The next thing what we said is that, so you see this is view from the top, how the sound radiates X, Y, but also you will have sound going up. We talk about canceling subs, so we took one and then we changed the polarity, flip polarity, 180 degrees on one, so there's no sound going out at all. Just to explain what happens when you have half wavelength offset into two sources with the same signal being played. So the next thing what we say is explaining cardio subwoofers. When do we use it? When we want to have a clean stage, or when we have any undesired reflection going to the back and messing up our signal in the front. So there are several ways to do it. Could be end fire, which is one subwoofer in the back, one subwoofer in the front, and basically aligning this one to this one. So basically delay this guy. The advantage is you don't lose impact in the front when you're listening to it, but it takes more space. So sometimes people say, oh, you have the stage here, there's no space to do this. That's a problem, especially in installations, clubs or theaters and stuff like that. The other configuration will be it's called FB, from back, where you just take one subwoofer, it's reverse, and there's a special processing applied to it. Usually you will select a center frequency in the back that you want to cancel, and then you will match gains, and then flip polarity. And that will produce a great level of cancellation in the back, but also you lose a little bit of impact in the front. Those are the two most common techniques of cardio sub. We say cardio sub, same as the cardio microphone. So we say cardio. So same as the sub will not send sound to the back. Well, needless to say, red is louder, green is quieter, blue is no sound, okay? So that's the reference we are using. So this microphone is also cardio. Means that the back is not picking up any frequency. So if I try to speak from here, you won't hear anything. But if I speak from the front, yes. So the subwoofer will be the same. From the back there is no sound being emitted, only to the front. Yes. No, both play the same scene, but just delay. So the front back, what you do is you have to. I mean, most of the manufacturers will give you the preset, but what you do is matching the gain at the frequency you want to cancel. So you say, I want to cancel it at 50 hertz. So you will measure in the back, pick up 50 hertz from the front, the one facing front, pick up 50 hertz from the one facing back, match the gains, and then maybe have to adjust the delay a little bit, and then you just flip the polarity on one of them. And then that frequency will be cancelled totally in the back. It messes up a little bit in the front. Supposedly you still gain because it's still emitting to the back, so it's still sending sound to the back, but it's not as much as is this one. So when you sum up two subwoofers, like for example in this configuration, you will gain 6 decibels, right? If it's in this configuration, maybe it's 4. It's not, but in this configuration you don't really lose any SPL. Same loudness. But what I mean is the front. What I mean in the front is in the audience zone. So when you do this configuration, they don't sum up that much. When you listen to it, it's not as same loudness as if you have standard subwoofer configuration, or it's not as loud as this one. Lose a little bit of SPL. Sure. So these subwoofers play from the frequency responses from 30 hertz to 70 hertz. So on cardio setups, it's difficult to cancel at all frequency range. So you will have a center frequency, you have your maximum cancellation, and then the rest you have still some spurious sound going on, which is what you feel. Probably the very, very low frequencies is still going to the back. You have to delay. This one has to wait for this one because we are listening here, right? ตอนนี้เป็นออกก่อนใช่ไหมฮะแต่อยู่ใกล้ๆใช่ไหมครับต้องรอสักครู่ครับรออันนี้มาอันนี้ถึงมา So if you don't have a preset from the manufacturer, what you do is you measure it, and then you measure this, you measure that, and then you will see the time difference, and then just put on the delay on the system. That's it. Whether the FBs, it's more complicated. The good thing of the FB, for example, in the scenario where you save space, and also when you fly subwoofers, which is another topic. But when you fly subwoofers and you want them flown and cardio, that configuration is preferred because you save rigging points, pretty much. There are some manufacturers. This box is cardio inside. So basically, they have a port going to the back. 2 ports. One or two ports. Depends on the box. The T sub is one port. This one may have.
Isn't this Y sub?
Yeah, but not the T sub, but this is T series.
Okay.
So they will have a circuit channel in the air. So when it goes out on the back, it will cancel on the front. It will be delayed by the channel in the air. So some manufacturers apply that kind of technique inside the box already. So it depends.
So this isn't going to be a training on cardio subs, but we can do more if you have more questions afterwards. So the next one would be starting to space the cabinets apart. คือถัดไปก็จะเป็นเริ่มจะเป็น array คือลำโพง2ใบนะครับซับวูเฟอร์2ใบมันจะเริ่มเป็นรูปทรงแบบ figure of 8แล้วเนาะคือจะเริ่มแคบด้านข้างเริ่มส่องไปข้างหน้านะครับถ้าคิดง่ายๆคือลำโพง2ตัวคือถ้าสมมุติว่าเป็นตัวนี้กับตัวนี้มาที่ผมไม่พร้อมกันซึ่งต้องเป็นคงฟิลเตอร์อยู่แล้วที่นี้ต้องหักหลังกันทีนี้นั่นคือข้างๆก็จะเริ่มแคบลงแต่ด้านหน้าระยะจากตัวนี้ไปที่นี้ระยะจากตัวนั้นไปที่นี้ก็ใกล้เคียงกันมาพร้อมกันอยู่แล้วซึ่งไม่ได้หักหลังกันคือไม่มีคงฟิลเตอร์ข้างหน้าโอเคแล้วถ้าดู4ใบนะครับthank you 4ใบก็เริ่มจะมีแคบกว่าเดิมอีก2ข้างหน้าและ2บนวิธีนะครับ
At which frequency is this?
This was 50 อันนี้50 Hz นะครับใน simulation และไปอีกก็จะเป็น8ใบนะครับลองขยายที่ละcan you go to the next slide ลองขยายที่ละนิดนะครับก็2หน้า2หลังด้วยข้างๆก็เหมือนเดิมนะครับไม่ได้2เท่าไหร่อันนี้จะเป็น electronic arc นะครับ electronic arc ก็จะดีเลย์ตัวที่อยู่ริมๆนะครับให้มันเป็น2แบบ2 arc so this one is going to be delaying the outer boxes to try and get an arc shape no, you can do it physically but it doesn't work quite as well as with the electronic basically it's the same kind of thing as just having 8 boxes straight but starting to widen up to the sides again so it gives a very good impact but if you make your line too long so that you get many different arrival times coming in then it can be detrimental to impact as well
So we know why this is happening, right? These cancellations. Different time arrivals at this point between different subwoofers. Right? So depends on the frequency, depends on the listening area. You will have that. Yeah. เข้าใจไหมครับ
Should we try 3 boxes wide?
Usually, I don't remember what was the next slide.
Then we start to go into more advanced ones.
Usually we keep it as a one source, as much packed together, better. So
we can try packed and spaced.
That kind of thing. We can play with it. Maybe we play music instead of pink noise, or we can play single frequencies. Can do 2 single frequencies, right? Maybe like 63 hertz, something like that. Okay, let's play. Let's try to play with it. Let's put them together, and then we start to put them apart and see what happens. For sake of ease, I would say start with plastic first, right?
Yeah.
Remove one cluster.
Which clusters you got? I'm playing all of them now. Which one do you want me to cancel? Which one do you want me to close? Huh? Everything. All. Everything. Okay. closer.
Switch off this one. Switch off the one with the polarity inverter. Going up. Because we switch off the one. This is phase 101 troubleshooting before any concert that many people don't do. Yeah, when we happen with the subwoofer, is we go one by one, literally. One by one, and with no software, with the system, okay, summing up. Sometimes you have the cable, or usually the cables are standard, but it can happen if you open and you do too much, like now it's polarity shift.
No, I put it back to normal now.
Only one,
This is one box.
one box,
Yep.
two box, and the other two. Right? Three frequencies together, so you move around. That's already because of the distance. So this is just one frequency of okay, this is a booster, right? So you have to people will say, oh, why did you use stereos up? Why did you use center and stereo? It's not just facing apart.
Quiet over here now.
Huh?
Quiet here now.
Sorry?
Quiet here now.
Now you go around.
Yep.มีทั้งห้องแล้วทั้งระยะ
So clearly, right? The maximum distance, different distance. Even more apart.
Do you want to just do the slide on LR subs quickly? There you go.
So now we go to left right. The boofer, which is going to be difficult to do. So we went from center, even in center you already have cancellation. Now we go left right, which is very common, right? Your point source is here, and we go right from there. Only one frequency.โอเค รู้สึกเป็นยังไงครับ You can work here too. You can work as the audience. So it's the two on the side. The center one is not working now.
ห่างเยอะเหมือนกันนะภาพก็ห่างโอ้โหถ่ายจริง
Do you believe in comb filtering?
รู้สึกเป็นยังไงครับ
อ๋อเดี๋ยวขอโทษ ขึ้นก็ได้
what is the problem.
Really?
They say, oh, we need to put them together. นายพูด I used to use this drug before. Now it's up by that's all.
โอเคนะ อยากจริงก็ลองได้นะข้างบนใช้โทนเดียวกันก็ได้ ลองดู
ลองดูไหม
ขอเปิดข้างบนหน่อยครับ เดี๋ยวผม แล้วปิดปิดแล้วใช่ไหมโอเคเป็นยังไงครับเสียงควบคุมพื้นที่ได้ไหม
ดีหรือไม่ดี6 dB จุดที่นั่นไหมครับ
ไม่
ใช่ครับเนี่ยถูกต้องครับถูกต้องครับเป็นก่อนโปรโมเตอร์บอกที่นั่นนี้เป็นมีราคาพิเศษทำไมพิเศษไม่เป็นไรครับเป็นพิเศษจริงๆครับไม่ได้ฟังอะไรเลยครับ80 Hz all your bass ไม่มีเลยไม่เป็นไร So you realize when you are at the same distance between both sources, you get full boost, like a maximum summation. When you are, it changes. So you could draw like a flower almost, right? So you have like a lobe, a lot of sound, no sound, like a lobe. So it's your comb filtering, but in a different shape, right? A comb filtering, let's say, in a 360 degrees. These kind of shapes. Depends on the frequency, it will change. The higher the frequency, the more lobes you have. The lower the frequency, less lobes. This is called power aisle. How to say aisle in Thai? Power aisle. Power alley. ไม่รู้ Power aisle. So it means that you have an aisle on the center where you have full energy.
ซอย power
ซอย power ใช่ซอยกันแรง And then you have other areas where there's basically nothing. So front of house in the center, so jot. Doesn't care anybody. Oh, sound is good. Life is good. Why we have to change, you know? It's everything to jot. ไม่เป็นไร But you already see, right? So this is just one frequency with two subwoofers. And okay, we are in a room with some sort of acoustic treatment. Things get really complicated. What's next? So this is your left-right subwoofer. Is it ideal? No. We usually, well, we have some technique that we should explain. We usually separate. What can we do to minimize this problem? มีไอเดียไหมครับเป็นวิธีการเป็นช่วยไม่มีปัญหานี้เป็นมีไอเดียไหมครับเราทำอะไรครับเราบอกแล้ว EQ ไหม Sorry, you have a question.
Could you ask the question again?
So what will we do? What did we say before that we can do when we have a stereo subwoofer, left and right? What do we do to minimize this problem? No, because gains should be the same. Huh? Sorry? Move? The สถานที่บอกเปลี่ยนไม่ได้เนี่ยเป็นติดตั้งอยู่แล้วครับครับเปลี่ยนไม่ได้ครับไม่มี DSP ครับอันนี้เป็น real life answer Can do. We say before, when comb filtering is happening, the main condition is two sources with the same. Yes. So, to minimize this, what we do is send left and right. So we differentiate. We split the signal. So usually, if the sub is in the center, we sum left and right. We do summation. Left and right channels. When we do left and right subwoofer, we split into left channel and right channel. So try to minimize the correlation of signals. Try to minimize the amount of signal carried by the both sources, similar signals carried by the both sources.
So I would say this approach works for like floor tom. Maybe the lower end of synthesizers if you have them going to subs, but for kick drum, very rarely do you want it anywhere other than center. So in the case of kick drum, bass guitar, not much you can do.
Yeah.
You live with it and the show goes on.
It's called suck it up.
Yeah. So I will explain a bit more on the good points and the bad points of each one. So just then we heard one frequency, left, right, but we didn't consider the transition to the main loudspeakers. So 80 hertz is going to be in subs and in mains นะครับคือความถี่80 hertz ก็จะอยู่ในทั้ง subwoofer และทั้ง main ด้วยก็จะเป็น2 source ในแนวตั้งด้วย ไม่ใช่แค่แนวนอนอันเดียวแนวตั้งด้วยซึ่ง left right ก็จะช่วย summation ระหว่าง subwoofer กับ main เมื่อ main ของเราเป็นสายขวาเหมือนกันแต่ไม่ได้ช่วยให้มี sub ทั่วสถานที่คือเรื่อง impact เรื่อง bass drum ที่เข้ามาก็ช่วยได้นิดนึงแต่อันนั้นแปลว่าเราไม่สนใจ bass guitar เลยคือ bass guitar ที่เป็นความถี่อื่นๆช่างมันand then the other one hang on I need to translate that so that's like the impact when you have your subs and your mains here so you're going to have 80 hertz in subs and in mains going this way and this way so when you got your subs left right it can help this time domain difference so your subs here your mains up there the time might be quite similar but it doesn't help for the other frequencies that they're not playing together so you have to kind of choose which one you want to live with when you have your array at the front here okay the subs to mains transition may be worse but the subs may cover more of the venue so it's like you're choosing bass guitar over kick drum or something essentially
the other thing is also to consider that maybe somebody asks when do you use one and other some venues that are not too big where you still have room modes we don't know there is no software that will simulate what can happen at 50 hertz which seems a little bit astonishing in 2023 we still don't know that so sometimes we guess we try okay for example doesn't work in left and right or we put it in the center in mono and it gets blurry and then we walk because the room will change too will have this kind of effects come filtering itself so maybe you change the way you excite the room by putting left and right and you get less of that room modes or you get modes in a different pattern and it sounds cleaner and better sometimes it happens it's difficult to say exactly when do we use one configuration or other but as Simon say give you a good guideline considering open air like there is no boundaries there is no walls and ceilings
เดี๋ยวมีผมจะยกตัวอย่างงานที่เชียงใหม่ที่เจอภูมิครั้งแรกมีซับแค่2ใบนะครับแล้วลองหลายตำแหน่งมากคือตอนแรกๆลองสับตรงเซนเตอร์ทั้งคู่ก็ไม่ชอบลองสับซ้ายขวาก็ไม่ชอบลองแบบสเปซหลายแบบลองเอ็นไฟร์ก็ไม่ชอบคือสุดท้ายเหมือนงานค่อนข้างใหญ่อยู่เนาะคืองานประมาณพื้นที่น่าจะลึก30 เมตรสุดท้ายใช้แค่ฟรอนต์แบ็กจุดเดียวแล้วก็พอคือแต่ละสถานที่ไม่มีถูกไม่มีผิดมีแค่แบบที่เหมาะสมกับงานนั้น
This can apply for your studio or for your live sound Impact Arena Rachamankara sound system design Jesus Christ, a lot of text. Okay, so we will go to, stand up with us, huh? Don't get sleep. There's a lot of text, but we will go one by one, okay?
อันนี้คือก่อนที่จะออกแบบระบบเสียงคือเรารู้ปัญหาแล้วว่าปัญหาหลักที่จะมีในห้องในสถานที่จะเป็นอะไรเราต้องคิดอะไรเพิ่มเติมก่อนที่จะออกแบบระบบเสียงในห้องนั้นก็เป้าหมายแรกนะครับความดังเราอยากให้ใกล้เคียงกันทั่วสถานที่นะครับคือ that's the similar SPL over the audience area so not more than 6 dB difference similar frequency response ก็อยากจะได้โทนใกล้เคียงกันทั่วสถานที่เหมือนกันนะครับไม่ใช่ว่าข้างหน้าแหลมมากหลังห้องเหมือนได้ยินแค่ทุ่มๆไปเดียวแบบอันนั้นก็ไม่ผ่านเหมือนกันsource localization is another one. So we don't want to have the arrays up too high. We don't want to have, in a performance venue, to use ceiling speakers instead of mains. This one you see in hotel ballrooms a lot, is you'll see ceiling speakers, and for any speech event, they will use the ceiling speakers. The good point is you get lots of direct sound. The bad point is it sounds like shit. So you choose what you want. Um, good stereo like localization for LR. So usually indoors, like indoor events, not a big problem. The width that you can have for your LR system is not too weird. But for festivals, nowadays the stages are 30 meters, 40 meters wide. Anyone is just listening to one loudspeaker at that point. นะครับคือปกติภายในพวกระบบ LR ไม่เคยมีปัญหาเท่าไหร่แต่ถ้าเป็นงานเฟสติวัลงานกลางแจ้งเวทีสมัยนี้มันกว้างมากแบบ30-40 เมตรจากลำโพงซ้ายไปลำโพงขวาก็40 เมตรคืออันนั้นหมายถึงว่าเราอยู่ตำแหน่งที่ไหนก็ได้เราฟังลำโพงแค่ตัวเดียวไม่มีสเตอริโอเลยนะครับก็ยกเว้นอยู่ตรงกลางจริงๆที่ front of house ถ้า front of house อยู่ข้างหน้านะปกติ
You saw some topics on Facebook like there's a famous festival opener in Thailand happening in December in the mountains.
in a large mountain.
In a large mountain in Khao Yai. And the latest couple of years they put the front of house like somewhere in a corner somewhere like.
แต่จะยกตัวอย่างHarry Style เขาไม่มี front of house นะครับเขามีตู้คอนเทนเนอร์อยู่หลังเวทีแล้วเขามิกหลังเวทีเขาใช้หูฟังเท่านั้นก็อันนั้นคือโปรโมเตอร์เขาบอกว่าอยากจะขายบัตรเยอะๆแล้ว front of house บอกว่าไม่ได้ยินลำโพงเพราะว่ามีเหมือนสาวๆแบบกรี๊ดกันเยอะก็เขาเลือกนั่งในห้องแทน
And then if the speakers are broken like, I'm just listening my headphones everything is good right
Okay for LCR system so LCR is left center right and lots of people fuck it up so center needs to cover the whole venue if you have my voice just coming out of one place everyone needs to hear my voice but if not everyone can hear the center then there's no point in doing left center rightโอเคอันนั้นคือเกี่ยวกับเสียงเป็นหลักนะครับแล้วมีไม่เกี่ยวกับเสียงด้วยนะครับ
So sorry so this is we are wrapping up we explain to you which type of speakers you have which kind of configurations you can use so when somebody asks you to do a design these are the things the key topics to keep it in mind okay
จอ LED สำคัญมากสมัยนี้ห้ามบังจอนะครับก็เราแต่งานจริงๆคือถ้ามันจำเป็นถ้าเสียงจะแย่ถ้าเราบังจอก็ต้องยอมว่าบังจอนิดนึง
This festival in the mountains is
แต่
we
ปก
want
ติ
to see the LED and we want to take the picture from the center exactly where the front of house is
คือปกติเขาจะบอกห้ามบังไว้แต่บางครั้งเราต้องอดทนนิดนึงเนาะบางครั้งจะมีแคทวอล์กอยู่ตรงกลางเราไม่สามารถวางซับวูเฟอร์ได้ก็ไม่ทำอะไรไม่ได้หรอกคือต้องเลือกตำแหน่งที่เหมาะสมอันนั้นไม่ใช่แบบใต้เวทีนะครับคือไม่ใช่ใต้แคทวอล์กก็ต้องวางสักอาจจะต้องเว้นไว้หรือวาง LR หรืออะไรแบบนั้นก็แล้วแต่so for catwalks you don't really well you see them at a lot of festivals now and not so much live music venues but nightclubs they love to have their catwalks so it's going to determine where you can place your subs there's nothing you can do about a catwalk if they want a catwalk they have to have it so but on the other hand there might be just steps coming up to the stage steps can be moved to the side or something like that quite easily so you know that can be an option power availability is a big one where your cables will reach to so if you just have say a 16 amp breaker you can't put in a huge line array system you know you have to change power or change the expectations and cable lengths are a big one like usually the cables we have here are 30 meters. Much more than that is a bit too long. You have to step up in your cable size. นะครับคือขนาดสายเป็นสิ่งที่น่าเบื่อมากๆคือไม่อยากจะคิดเรื่องขนาดสายหรอกแต่ปกติถ้าเกินสัก30 เมตร ค่อนข้างยาวแล้วก็ต้องเปลี่ยนขนาดสายแล้วเพราะว่าจะมีความต้านทานในสายเยอะก็ต้องเปลี่ยนไว้นะครับเช่นสายลำโพงที่เรามีที่นี้ไม่รู้อยู่ไหนก็เป็นขนาด4มิลทั้งหมดคือ8ขอ4มิลถ้าอยากจะได้มากกว่า30เมตรก็ต้องเปลี่ยนเป็น6มิล8มิลอะไรแบบนั้นแล้วราคาก็แพงขึ้นเรื่อยๆrigging points are a big one so the weight loading of the structure and your available rigging points will determine where you can put your speakers. It's a big one. And front of house and VIP position. So where you want the good seats to be, where you have to cover, and where your front of house is going to be, and who's going to complain the most, essentially.
Mainly distance between the speakers, subwoofer positioning, height. Those are the three big main considerations to have your system performing properly. So yes, we finished point sources versus line arrays. So we'll jump to the next part of this training. Any questions?
I have seen front of house like the tower.
Yes.
Is that really work?
If you tower front of house usually is for very, very large festivals where they want to have maybe the equipment out of reach out of people's hands and stuff like that. You had to. The person who is mixing has to have that in consideration, and the person who designed the system has to have consideration where the front of house is and how much sound are you sending to that position.
But the sound can never be on the second floor. Always has to be downstairs. Second floor is lighting.
Some in the past they used the front of house on top too, like maybe above people's audience, right? They have those super high towers.
Yeah, like at Reading Festival, Youth Festival,
Okay.
but usually it's lighting and video on top.
No, but even like a sound like 3-4 meters high
Yeah.
was already, that's already a lot.
So we'll see in the simulation software, if you're higher up, that means you're getting energy which is meant for audience further back,
For the back.
which means you're going to get more high frequency, and you have to consider that when you're mixing.
So
So usually you have to walk down with the iPad and
your reference point is not the same as the audience is, or your ear height is not the same. In the simulation software that we will start doing now, you can set up the listening height, and then you can see the differences. So we will start to explain. So we explain
Okay.
point sources, line arrays, subwoofers. We will start to explain which softwares we use to manipulate and understanding when we deploy a sound system. There are many options. Each manufacturer will have its own software. Just as an introduction, so Adamson uses a software called Blueprint, which simulates all the speakers in their catalog in direct sound scenario. Basically, direct sound means there are no reflections. So the software will consider the first ray of sound to impact whatever we say the audience is, and that's it. It doesn't care there is a floor, there is a wall, there is a ceiling. But there are other softwares that do that. It's called EASE. Probably you heard about it. EASE is kind of acoustics and electroacoustic simulation software where you could define a room and say which materials are in that room. Like the floor is concrete, the walls are curtains with this density, and you can apply acoustic properties to the room, and then you can take. Some manufacturers have the license for it, some others no. If you have it, then you can apply your exact speakers configuration, and then it will simulate and it will give you what happens in the room until 100 hertz. Below 100 hertz, you don't know what's going on. It's totally blind. What we will do is Blueprint. These days, we will give you a little bit of a briefing of how the software looks like. This is not an intended blueprint training. It's just to let you see how a simulation software looks like, what are the parameters and the readings that we get out of it. And if you like it, if you want to learn more,
I was thinking I might do in parallel something on Blueprint and then how I would do in this focus or something. Would be a
is focus or is?
ease focus because I can't do all the two.
The question is in ease. I think we can just show you a little bit. We'll try to, this part can be a little bit boring, but we'll try to show you, but it's interesting too.
I think the main point is we're going to get to a venue, put up a line array, and then ask for which boxes we need to.
Yeah, the idea is you help us. We will not try to let you understand how to use the software. We will question you, and we will do a design for this room. So we will show you the inputs that we put in the software, and we'll ask you to help us to design how we should rig this and how we should put the subwoofers in this room, because we will listen it and we will rig it up tomorrow together. Okay. To listen race against the machine properly, right? The big balls bass. And Black Sabbath.
ก็ซิมซอฟต์แวร์ที่เป็นซิมูเลชันทั้งหมดอันดับแรกเราต้องใส่ dimension ของสถานที่ขนาดของสถานที่ไม่ว่าเป็นกลางแจ้งหรือภายในก็เหมือนกันหมดนะซึ่งใน blueprint ก็จะมีเรื่อง floor มาให้ถ้าเป็น east focus do you do east focus here you do east focus in the do you learn east focus here no
Doesn't look like.
okay so ease focus is a free software where you can learn how to deploy line arrays check the angles and all of the method like all of the steps that we're going to do are applicable to ease focus sound vision array calc blueprint and anything you want so first of all before we put in the venue we have to know the size of the venue so I got a laser. Who wants to measure the venue for me?
Who want to measure the venue? The principle of this software
It's a good time to learn.
They can work in 2D and they can work in 3D mode. So you can draw based on floor plan and then add the elevations and then you can visualize in 3D. So you can see most of the softwares operates in the very same way. So you have your 2D view in this case, and you see the right window, you have 3 axes. So basically it's your X, Y, Z coordinates, so you can see what you have done in 3D. So we have to design for this room. So what will we measure? We measure the whole room or no? Or we measure, what do we measure from where to where? Track it now, hija. Yes, we are going to do the design to how to deploy the sound system. You have to do the design for tomorrow. So where do we measure? Feel free. Okay, what else? Okay, I have a question. Do I need to measure this? Why? But this software doesn't count the walls. It's direct sound. And there is no people sitting out there. To simplify things, just the audience area. Correct.
Another thing you can do is do the whole room and then just turn on and off the audience area if you want to use. But it's more work, takes longer time.
These seats are retractable, right? These seats can go back, right? All the way back. So for example, if we say it's a standing configuration, I think when we do the 3D sound, we will do standing, so all these will go to the back, and we will use the room as just like a box. Then yes, because anyone can be anywhere. But by the configuration, we are limiting the people to be seated on the seats, right? So to make things easier and quicker, I will measure only the seating area. Eventually, do we need to measure this part? Why not? Or why?
Value is slightly different.
I think we need to measure like this, like the speaker is like from here, like how far from the speaker.
We should measure this part to know where, because do we know where to rig? แขวนลำโพงรู้จักที่ไหนไหมครับเป็นฟิกอยู่แล้วใช่ไหมฮะเราเปลี่ยนไม่ได้ I think we will hang it from this truss. So we come to Mahidol and we say, oh, we are gonna do a concert. แขวนลำโพงไหนที่ไหนครับ truss นี้ครับโอ้ด้านล่างได้ไหมไม่ได้ Okay, fix position for your length. So we're gonna set up here. We need to know. So he's correct. We need to know what is happening in this area. So also what is happening with where the system start to work, where the coverage starts.
So if we can do just the standing area first, floor part.
Sure. So they're measuring already.
So if we can do the standing area here
Yes.
first, I'll put it in.
So do you want to
No. I just asked. I said like if, for example, in the future we do the room without the seats, then yeah, perhaps we have to measure everything because anyone can stand anywhere. But as we have the seating, the idea is
I'll stand
measure
on this side and you
just
can
the seating.
just aim at me essentially.
normal concert?
If you go to very
Everyone stand in the
Shy. It depends on where the people sit, where the audience area is. So what we gonna input on the software. Another thing is, if in the future we know we are gonna use this room for other purposes, maybe we measure everything, and then we put the seating, and then we can use with this seating configuration or with just the flat floor configuration too. So it depends. As a rule of thumb, wherever the people are seated is what you have to consider for your measurements. So what do we have?
โอเคเมื่อกี้เราได้วัดแค่ด้านล่างก่อนนะครับ
From the truss, right? From the below here. So the first thing we need to do is to set up our origin of coordinates, our point 0, 0, 0. Coordinates, right? Everyone okay, right? X, Y, Z. 0.0.0.0 so 0.0 ปกติแล้วใช้ 0.0.0 หน้าเวที usually it's on the exactly center front stage for me. Some people prefer to put it on the back of the stage. For me it's always the center of the stage, center front of the stage is 0, 0, 0. In this case we say we'll put it where the speakers are, so it's also easier for us to have the reference where the speakers will start. So our 0, 0, 0, it's here. So from here is X, X, no, it depends.
In blueprint is X, in East Focus is X.
Yeah, I always think in is. So it's X, Y, Z. So blueprint is switch. They are Canadian, so don't blame them.
โอเคนะครับเมื่อกี้เราได้วัดไปแล้วจากจุดเริ่มต้น 000 จนถึงเริ่มของที่นั่งแล้วนั่นคือ 4 เมตรนะครับทีนี้ความกว้างของที่นั่งทั้งหมดอยู่ที่15 เมตรนะครับซึ่งผมใส่ข้างบนไปแล้วที่ไม่มีลิดทีนี้อันนี้คือ x 0 และ x เป็น 4 นะครับคือ 0 อยู่ที่นี้4 อยู่ที่นี่โอเคนะความกว้างก็15 เมตรทั้งหมดนะครับฝั่งนี้ 7.5 ฝั่งนี้ 7.5 Did you say 15 or 15 and a half? 15.5 Okay my bad
So you will do the whole room first?
No just the seating and the standing in the front โอเคถัดไปก็เราต้องทำที่นั่งด้วยเหมือน Did you get to the seating bit yet? Not yet, right? So to the back of the room was how much? Yeah, to the very back.
So you can measure from, you can also measure, so if you know from here is 4, so you just target from here all the way there, so you already know the additional, and it's already sitting.
And how high are we? From the top and the sorry, from the last step. Okay, วนยิงลงมาจากพื้น Can you give me a hand quickly? We need to do from the step down to the floor.
Sure.
9 meters. Well, 9.01.
That much?
I did all the way up.
No. So we need to do from the upper floor. Yeah, Paul is gonna help you.
Oh, okay.
So he will measure from there down. So we don't need to know the height of the room because there is no audience up there.
Oh, right.
But we need to know where the sitting, the highest. ต้นรู้ขวัญศูนย์ที่นั่นเท่าไหร่ขวัญสูงสุดเท่าไหร่ปุ้มไม่ใช่ครับต้มปุ้มตั้นนั่น Okay, we have some technical difficulties. เท่าอะไรครับ No, because then in the software we say how high the audience are. 2.8 2.8 from the floor down or from the floor up สูงสุดที่นั่นไม่ใช่ที่นั่นปุ่มอยู่ที่นั่นปุ่มสูงสุด the highest floor right ปุ่มสุดพื้นสูงสุดพื้นสูงสุด
โอเคครับอันนี้คือมองจากด้านข้างนะครับที่เป็นภาพ 3D ซึ่งเราเห็นว่าเราไม่ได้ทำทีละชั้นทีละแถวขี้เกียจทำคืออันนี้เป็นแค่ simulation นะครับคือไม่ได้เป๊ะขนาดนั้นเป็นแค่แบบจุดเริ่มต้นที่เราจะคำนวณระบบเสียงยังไงก็ในห้องจริงๆก็จะแตกต่างกันนิดนึงแต่เราแค่ทำนี้ไปก่อนเพราะว่ามันรวดเร็ว
And actually it's not needed because if you trace let's say everybody sitting is here if you trace a straight line we don't do like this right so it's actually kind of right to trace a line that will line up everybody ears from all up all the way down this is the same as you trying to line up the upper part of the sitting all the way up is just a straight line. So you don't need to do the stairs and all that kind of thing. Again, we are trying to do a quick, another thing is an acoustic design, needs to have a more visual presentation, etc., etc., etc. Then maybe you have to consider
ภูมิช่วยเช็คสาย HDMI หน่อยที่เป็น output
But for acoustic purposes, good enough. ดีอยู่แล้วไม่ต้องเขียนเยอะ
โอ้เกือบได้แล้ว
Oh no แต่ฟันนี้เล็ก
over there โอเคอันนี้เป็นแค่พื้นเฉยๆนะครับขอโทษผมทำผิดนิดนึงแต่จริงๆพื้นข้างล่างก็จะเป็นพื้นที่ที่เรายืนฟังนะครับและอันนี้คือเป็นที่นั่งนะครับซึ่งผมจะเลือกความสูงคนละแบบจุ๊บนะครับคือที่เป็นสีแดงที่นี้จะเป็นระดับหูประมาณน่าจะ 1.77 นะครับและ 1.2
1.2 so standing average 1.7 standing seated 1.2 most of the software will have a seated or standing option so you can see here is sit so we click okay these people are seated here we keep like standing so we understand the people here are standing you can also click seated for
but we're going to stand here
well you can do we're not block the view does it matter yes so it's not the same you are standing seated in a more advanced designs, acoustic designs using ease, you have to consider the absorption of the seats. So that's a twist. This is a very quick way to do it. These kind of softwares from the speaker manufacturers are thought to any sound front of house engineer or system engineer arrive to a new venue. Shit, I have a concert. I don't know. They don't provide me the drawings or whatever. Quickly with a laser, boom, 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 take the measurements and he can input on the software and start to do the design and get a quick idea of how to deploy the sound system. So most of these softwares are thought to be a speed up process. Then, so you see this is the section. This is a third window which appears that we can change to see things like the cross-section of the speakers. We can see the distribution. We can see the spectrum. We can see the SPL distribution, how loud, in meters from front to back. And vertical SPL, which will be seeing the dispersion of the speakers on the cross-section.
ก็ที่เราทำเมื่อกี้นะครับคือมีเวนิวจริงๆประมาณนี้คือมีที่นั่งเยอะๆแต่ใน Blueprint หรือใน Simulation Software ต่างๆก็จะทำให้มันเป็นเหมือน Surface ง่ายๆคือไม่ต้องเสียเวลาวัดทางสถานที่เยอะก็เราเปลี่ยนเป็นพื้นเรียบและเอาเข้าซอฟต์แวร์ตามที่เราทำเมื่อกี้นะครับซึ่งปกติจะมีแบบนี้คือการภาพเป็นอะไรวะการวัดสถานที่จริงนั่นคือเราใช้เลเซอร์ตามเมื่อกี้หรือเราอาจจะมีภาพที่เป็น drawing จากสถานที่นะครับก็ใช้ได้ทั้งคู่อีกออปชันหนึ่งปกติเราสามารถวัดองศาก็ได้ด้วยนะครับไม่ถึงว่ายืนหน้าเวทีแล้วเช็คระยะและองศาแต่ละจุดนะครับก็ส่วนตัวผมชอบแบบ 3D ไม่ค่อยชอบวัดองศาเพราะว่ามือน่าจะสั่นนิดนึงก็องศาก็จะเพี้ยนซึ่งเราอาจจะได้ประมาณนี้คือเวนิวจริงมีที่นั่งเยอะๆมีลำโพงสองข้างแล้วใน Blueprint หรือในซอฟต์แวร์คนอื่นก็จะเป็นภาพใกล้เคียงกันที่จะไม่เห็นภาพ 3D ก็เป็น Ease Focus เป็นแค่ 2D เท่านั้นนะครับแต่คอนเซปต์ก็เหมือนกัน
Most of these softwares can import from CAD or can import from SketchUp, but you may have to clear some of the walls or whatever that you don't need, especially if it's direct sound software. Otherwise, it will load up the calculation a lot. So it depends on, again, what you want to do.
So when we add in our loudspeakers, our main array, usually we start with the main loudspeakers first. We'll put in the type of loudspeaker, the model. the quantity, the rigging position, any extra details we want to have associated, like a gain or something maybe. And then cabinet type, gains, positions, blah, blah, blah. And at the end of it, you'll get a picture, something like this, which is like a 2D cross-section of your main loudspeakers. What we've been saying all along is you want to have even coverage across the whole venue. You want it to be, some other brands will say, a democracy for listeners. They'll say everyone should listen the same. คือทุกคนต้องฟังให้เท่ากันนะครับขนาดยืนข้างล่างยืนข้างบนก็ต้องฟังให้เท่ากันนะครับและ so the next thing we have to look into is weightings. So we said a lineary has variable tonality depending on distance. So we need to look at different tonalities, different frequency ranges to make sure that they're the same, or we can get them as close as possible. So usually, if it's me, I will start with Y weight. That's looking at 2K to 8K. If it's in L-Acoustics world, maybe you look at 1K to 10K. If you're in Ease Focus world, maybe you look at 4K, 3 octaves. It's all the same. It's just you're looking at high frequency first. So we got 2K to 8K. And then we'll get something like this. So that's exactly what I've got in my, over here. Oh, it's over here.
I forgot to say, this is quite cool to see all the SPL, etc., but one of the main features of the softwares, most of the manufacturers, are safety. So how many speakers? How much weight, and how many hoist. In case of a large system, how many hoist and rigging points are you using, and what is the total angulation? And now it will calculate you the center of the masses. If the center of the masses is out of the center of the masses supported by the rigging point, it will send you a warning to don't rig the system. So I would say, prior to understanding the SPL is understanding that you can rig it up safely. We can actually do an example. Can you do something like put a lot of speakers and, for example, let's say we have even 8. No need to put too many. We have 8, and then we put it tilted like that. Immediately you see this red window, and it say no tension in the hoist. Means that this will fall down, and you don't want that thing up there to fall down. You don't want that. Especially if you have the...
Depends who's sitting there.
The dean of the university here, maybe? Maisanu. Right?
Okay.
It's a terrible thing to happen. It happened once, as far as I know, in Thailand, that the line array collapsed, fall, and killed someone a few years back. And that company has struggled quite a lot. So to do things serious and change the market, that you say you want to be front of house, you want to be artists, even if you are artists and you are in the stage, I would say you trust on your team, right? Or you trust on the rental company. But you can always say, can you show me how you rig that? I mean, you are going to be there, right? And if something falls, sorry? LED screens. Well, that's another thing, but we don't do LED screens, fortunately. Right? So it's a very easy thing. And still in Thailand, and I will emphasize this a lot because really at the end of the day, make it sound better or not, it's okay. Play with people live, it's another thing. And it seems that still not many people take that into consideration in here, in this part of the world. So please be careful with what you put above people's heads and on your heads, right? This is a big responsibility. So in this case, if Simon tried to put this thing overly tilted or overly either way up or way tilted down, the software will send an alarm. This should never, ever go in the air. The question, most of the softwares will offer you some sort of visualization of a mechanical part of the system, no tension on the hoist. It will eventually give you the rigging frame, which is this part up here. How many points are we picking up the system from? And you can change. You want one motor, you want two motors, you want to have a beam in the center, because most of the manufacturers also include different rigging options, like beams that you can have a little bit wider pickup points. Therefore, the center of mass, it falls in the center of the tension area. That's a beam. That will be on top of that frame to allow you over tilts or under tilts in extreme configuration like this. Another thing is if you want to do this or not, but it may happen, okay? So by changing even just one motor and just adding the beam into the system, it tells you, okay, now you can rig safely, but you have to put the beam in that position. It will give you exactly every single detail of where this beam is going to be pinned out and where is the lifting plate, which is the main point to rig the system from. Even if you just only use one hoist, and obviously you have to consider how heavy your system is, which is 236 kilos. So you have to consider that to know which hoist. Somebody can say, oh, I will put you a 250 kilo hoist, enough. ไม่ต้องเป็นขี้เหนียวเป็นขาย500ได้ไหม This is for me the most important feature to avoid people do nonsense. Another question, do I have anything personally against local manufacturers or Chinese manufacturers? Yes, I do. This. Usually they don't employ these features. So, oh yeah, that brand, it's okay. It's cheap. Yeah, it's cheap. Things are cheap for a reason, and things are expensive for a reason, okay? So, for me, this is one of the things I want you to learn from here is wherever you go to a stage, and if you are involved on that show, whether you are an artist, whether you are backstage, whether you are front of house, it's always to just asking. There is no standard in Thailand. There is nobody from a safety department asking, oh, are you wearing your boots? Are you wearing your helmet? Are you rigging the system properly? It doesn't happen in Europe. In Europe, you have somebody from the town usually going into the venue and asking for licenses, asking for these kind of details and verifying that it's all correct. Somebody no helmet, stop the show, stop the mounting. Okay, in Thailand now it's improving, at least on the personal safety point of view. I don't see that many people wearing sleepers and rigging speakers, but I don't see that many people wearing helmets. And I always wear a helmet. We should bring tomorrow a helmet. And but there's no heavy rigging, right? Imagine just one pin like this. If it falls down from up there, it make a hole in your head. Stupid, huh? This fall down. I mean, obviously it has a safety sling, but imagine something breaks, it falls down, it makes a fucking hole in your head. Yeah, we have one. Yeah, we have one colleague, right? He is the application engineer for Adamson. He lives in Thailand. He has a lot of experience. He worked for Rolling Stones and Pharrell and Maroon 5, large tours. He was in a Rolling Stones tour or Maroon 5, I think. The Stones tour. Somebody fall down a screw or a shackle or something. Okay, so that's, we don't want to scare you, but please, ไม่ต้องเป็นมังง่าย don't be มังง่าย มันง่าย เป็น like อะไรก็ได้ไม่เป็นไรไม่ใช่ไม่เป็นไร Okay I think I emphasize that a lot
ขับมาที่เสียงเนาะ Okay so
the safety first
Safety first,
I
yeah.
don't care เสียง safety ก่อน
So we're gonna aim these loudspeakers over the venue. So if we come back to here, this is what we might think if we just said, we just put the speakers up and curve some at the bottom. So you got a laser. So this is what someone might do if they didn't simulate. This is the distance, and this is loudness, SPL. Looking at high frequency only. So we say, it's quite loud on the balcony here, but below is not very loud, not so much high frequency. พอมองออกไหมคือนี่ระยะนะครับนี่ความดังแล้วตอนนี้เราดูแค่ความดังที่ความที่ศูนย์เท่านั้น 2K ถึง 8K พออยู่ชั้น2ที่บัลคอนี่ข้างๆดังอยู่ที่เป็นสีเนิ่มๆนะครับแต่ข้างล่างสีแดงไม่ได้ยินสิ่งแหลมน้อยมากแปลว่าไม่ได้ควบคุมสถานที่ขนาดเราใช้ลำโพงเยอะเราเป็นเกือบเจแล้วก็ยังควบคุมสถานที่ไม่ได้พอเราดูภาพถัดไปนะครับเริ่มจะดูดีนะครับสีแดงความดังค่อนข้างโอเคแล้วความดังใกล้เคียงกันหมด so it's like on red you get very smooth SPL here blue you got very smooth SPL but if you look here there's people sat here at the front and they can't hear anything so it's not just smoothness of SPL it's making sure everyone can hear it so we got to do something about these guys here นะครับคือข้างหน้าไม่ได้ยินเราต้องเสริมตรงนี้แต่ทรงของ SPL shape ของ SPL ค่อนข้างโอเคคือเริ่มค่อนข้างดังแล้วค่อยๆดรอปนะครับไม่ใช่ว่าหน้าห้องมันเบาแล้วหลังห้องมันดังเราอยากให้ภายใน6 dB แต่ค่อยๆดรอปค่อยๆเบาลงมาทีนี้มีปัญหาอะไร Any problem here Yeah, right. Yeah, so now we cover at the front, but in the middle at the back, still can't hear it. So in the end, we might end up with something like this. We get good SPL here. We overshoot just a little bit to make sure that if you stand up, you can still hear. If you jump, you can still hear. คือหลังห้องเราเกินไปนิดนึงเพื่อแบบถ้ากระโดดท่าเต้นก็ยังได้ยินแต่ไม่ได้สะท้อนเยอะจากผนังหลังอะไรแบบนั้นก็พอดีเราค่อยๆ drop ลงมาหน้าห้องก็ได้ยินนะครับเรา front fiddle ของเราควบคุมแค่ประมาณ4เมตรก็พอทำได้ถ้า front fiddle ควบคุม10เมตร20เมตรก็มันเกินหน้าที่ของมันนะครับ
Also depends do I have front fills do I need front fills do I need to bring the image down so there's many questions right but just with the main system you can see you can achieve good results already
and then we'd look at a different frequency range so then once our Y weight once our high frequency is finished we then start to look at A weight so A weight brings in more mid frequencies and compares them so we say if our high frequency drops off like this that means our mid should drop off like thisเข้าใจไหมคือแหลมของเราก็ตกแบบนี้อันนั้นคือ mid คือ A weight ของเราก็ต้องตกให้ใกล้เคียงกันซึ่งเราต้องเทียบกันว่าไม่มีจุดไหนที่มี mid เยอะไม่มีแหลมหรือมีแหลมไม่มี mid อะไรแบบนั้นคือต้องเสมอต้องขนานกันตลอด
A weight is more like how would you expect the ears to work as well so when you look at A weight is from a musical point of view is more like how you are going to perceive the sound or the SPL variation for all those range of frequencies at a normal volumes Have they studied DBA, different weightings and ponderations? Fletcher-Manson curves. So, okay, so here is your Fletcher-Manson applied. When you work in the studio, also you have to have that in consideration. At what level is the music going to be listened to?
Okay, so let's look at this room. So we've got, I did 8 loudspeakers first, just to see what will happen. So 8 loudspeakers in one cluster. And
I will ask, what do you want to do tomorrow here? You want to do stereo? You want to do mono?
stereo.
Stereo? Okay, who wants a stereo?
Me. Immersive.
Yeah, one speaker. Who wants a stereo? Or who wants mono?
I think both. Let's do both.
I'm not sure we have time. So, not sure, stereo or mono? Stereo, mono, stereo? For tomorrow. Tomorrow we need to rig the speaker. พรุ่งนี้เรากำลังแขวนลำโพงแต่ตอนนี้เรากำลังทำออกแบบอันนี้ต้องคิดเอาซ้ายขวาหรือโมโนอย่างเดียว
I can go down to 4 first. Let's try 4, so we do in stereo first. So the first thing we have to do is choose our height, our rigging height. So default here is 10 meters. Can we fly at 10 meters here? Quite high.
Laser ศูนย์เท่าไหร่ครับ Who wanna check the height? Okay. So the highest point will be the black bit of hoist. ถ้าสูงกว่านี้ก็ได้นะ เท่าไหร่
ประมาณ 6.3 เมตรนะครับ
6.3 เมตรทีนี้
ณ ตอนนี้
แต่มีอีกไหม มีประมาณ1 เมตรสูงกว่าได้1 เมตร
ต่ำกว่าได้ไหม เดี๋ยวจะใส่6 เมตรไปก่อนแล้วกัน และเขามีฟังก์ชัน Auto Shoot ใช้ Auto Shoot ไปเลย Auto Shoot work ไหม เราจะเห็นไม่ค่อยชัดเนอะ
So distance and SPL. We're looking into dBY. So we are looking from an average from 2 kilohertz to 8 kilohertz octave. So อันนี้ดีไหมครับ อันนี้เป็น6 dB. Every division is 6 decibels. So we start to have sound around 3 meters maybe. And then it go up, and then goes down around 40 meters. อันนี้ดีไหมครับ ดีหรือไม่ดี It's within 6 dB, right? Yeah, 6 dB แล้ว And this line here is this part, which is this part. There's nobody sitting out here. We don't care. ไม่มีใครฟังอยู่ที่นี่แล้วส้มใช้คนที่นั่นอยู่นี่ฝั่งนู้น which is this line from this you see this red bit is that so this will be the section this will be the SPL อยู่ใน6 dB แล้วต้องเปลี่ยนไหม
Let me show them quickly what's going to happen. เดี๋ยวจะลองปรับองศาแล้วดูว่าเส้นมันเปลี่ยนแปลงยังไง ถ้าผมใช้เลขน้อยอันนั้นแปลว่า line array จะตรงกว่านะครับ ซึ่ง line array ตรงกว่าต้องเกิดอะไรขึ้นจากสิ่งแหลมกับสิ่งแหลม จะมากกว่าเลยจะน้อยกว่ามากกว่าลองดู
so each line is the axis of each speaker so you can see where is each axis targeting
Okay, so now we adjust the first box to 0 so they're going to be flat
so
and we
0
get more HF at the back
will be
wrong frame you just take the pins out
With no angles, each position has different angle, but let's see. Distance, the angle between boxes, is very there, and these boxes, and the boxes. So that would be 0 อันนี้โอเคกว่าไหมครับ ดีขึ้นไหมครับ Give them some time to think. Where is the point?
ยกตัวอย่างนะครับแบบนี้ดีไหมคืออยู่ในช่วง6 dB นะครับจะดีไหม
ต้นเรื่องไหม
ดีกว่า
ว่าไหม Why?
คือถ้าเราเริ่มต้นสายมือนะครับอันนั้นแปลว่าอยู่ข้างล่างแล้วค่อยๆไปขวามือนั้นเดินขึ้นไปนะครับซึ่งเริ่มข้างหน้าเสียงจะเบาแล้วค่อยๆดังขึ้นเหมือนไม่เคยธรรมชาติจริงๆถ้าอยู่หลังห้องก็ต้องเบากว่านิดนึงเนาะ
We don't expect the front to be louder than the back. Again, within 6 decibels or as much equal as possible, but we don't want the back to be louder than the front because it's not normal. Our brain thinks the farther you are, the quieter it gets. Which means it doesn't need to be quieter, but it doesn't need to be louder. So it should be equal or a little bit quieter. That would be our design approach.
Would you want the next one to be the 4-point sources?
Yeah.
โอเคครับอันนี้คือตัวอย่างหนึ่งนะครับความดังที่6 เมตรอยู่ที่118 dB ครับความดังที่12 เมตร อยู่ที่ประมาณ113
ดีไหมครับ
อันนี้เป็น line array ไหมครับถ้าดู C wave ดีกว่า133ถึง127เป็น point source นะครับตกลง6 dB จาก6 เมตรไป12 เมตรก็เราแขวน line array แล้วสื่อตังค์สื่อค่อนข้างแพงนะครับ
So
แต่
you
ก็เป็น
see
point source
8 boxes, sorry, 4 boxes, 8, which is the maximum angulation like this. We measured it this morning, do you remember? So we put it straight, so the high frequencies were more closer to each other. When we open it up, the high frequencies were almost 6 dB, so you can see here. Now you can also think about up there. What's going on? Now you can also think what's going on up there. So we are just changing just 4 boxes and combinations between the angles and where are we targeting each box. You see things change a lot. Only 4 speakers. เปลี่ยนเยอะ so chances to fuck up a lot อันนี้ดีขึ้นไหมครับ so we comparing now dBA with dBy so high frequencies versus high frequencies with mid-low frequencies average should be parallel, right? Or no? We say it should be similar tonal balance. So you should not have more lows in the front than in the back. Should not have more highs in the front than in the back. Both curves should be parallel.
It's about as good as you're going to get with 4 boxes.
Yeah. I mean, I can do this one with the point source.
Yep. อันนี้คือตัวอย่างว่า point source น่าจะง่ายกว่า และคือควบคุมได้เหมือนกัน เมื่อเราใช้ point source ใหญ่ๆแบบอาจจะเป็น10 นิ้ว 2 ดอก 12 นิ้ว 2 ดอกอะไรแบบนั้นควบคุมง่ายคือความดังพออยู่แล้วแหละและโทนมันจะไม่เปลี่ยนไป ที่นี้เราเห็นว่าที่แถว8 เมตรนะครับแหลมก็จะตกนิดนึงแต่กลางยังมีนั่นแปลว่าจุดนี้คืออาจจะฟังไม่ค่อยดีเท่าไหร่
Maybe we can bring the 10 piece tomorrow and hang one.
Can do.
We can bring one point source, one big point source that we have, bigger than this, and we can compare line array versus point source for this venue because I think it's on the edge of to do with a point source, one speaker.
Okay.
So
So I think we just go into stereo on this and then do a bigger venue and do more boxes.
So you see, to use line array for certain applications, the conclusion that you should get until now is certain size of venues doesn't benefit of the use of a line array, especially for small configurations like 4, 5 boxes. Maybe you can find a way to use a big point source. I would say up to 15 meters indoor, 15, 18 meters, you can use a point source. Obviously, you have to consider how loud it has to be. Therefore, you can consider the size of your point source.
Okay. ตอนนี้เราเห็นว่า
Can you click here?
Sorry. Which one?
The red one.
My eyes aren't so good. ตอนนี้เราเห็นว่าจากที่ดังที่สุดพีค120 dB นะครับจนถึงที่หลังห้องเป่าสุดนะครับ116 dB ก็บวกลบ2ได้อยู่นะครับ
Can you click here?
อีกไว้
One more.
เนาะตรงนั้นน่าจะไม่ได้ยิน
Yeah. So that's 8 dB. 120 to 112. Not approved.
Run out of boxes.
More budget.
Yeah.
Buy more speakers.
Buy some front fills.
Buy some front fills, maybe. So, design principle, we had to think like, hey, the people sitting down here may not be listening that much.
เมื่อกี้เราเห็นว่า simulation ที่เป็นภาพ 3D เราทำเป็นขั้นตอนสุดท้าย จริงๆ เราสนใจภาพ 2D มากกว่าว่า tonal balance ความดังจะเป็นยังไง และด้วยภาพ 3D เราจะแค่จะเช็คระยะระหว่างลำโพงเฉยๆ คือถ้าเราเห็นว่ามันช่องกลางมันหายไป เราอาจจะแขวนให้มันใกล้กว่า ถ้าเราเห็นว่าแบบต้องมี outfield อะไรเป็นนั้นเพิ่มอาจจะเพิ่มทีหลัง แต่หลายๆคนก็จะเปิดภาพ 3D มาก่อน แล้วบอกว่าภาพสวยดังทั้งหมด แต่จริงๆ tonal balance อาจจะยังไม่เหมาะสมนะครับ so just saying like the 3D is our last thing that we do just to check the width between the speakers. So most of the work is done in 2D to check tonal balance, to check SPL. And then we're just kind of double checking in 3D eventually.
This graph usually is the most important to check how is the high frequencies dispersion. We can also see, can you change to dBY and see in 3D? We can also see high frequencies only. Ah, okay. Ah, okay, sorry. Yeah.
And then if we go to...
So you can, most of the software will allow you to change the resolution of the calculation. So this software works by having a grid, basically, on the audience area. And then you can, let's say, they will have measurement points all around the audience area. So you can determine how much is the spacing of the resolution, how many measurement points you want on the audience area. The more resolution you add, the slower the calculation is, usually, especially for large venues. So sometimes when we use very large places, if we have done Impact Arena or Ratchaman, we trying to don't have too much resolution in order to speed up calculation or buy a expensive, powerful computer.
Try a new design.
For me, it's fine. We optimize this one a little bit. For tomorrow,
Pretty okay, I think.
why don't we just, yeah, you can do, you have Ratchaman there?
No.
In the server. Soon, maybe in 20 minutes. Can you open Ratchaman?
It's just going to be like a nice easy one and get them to...
Download Ratchaman has Ratchaman. So these are the principles. So maybe
อยากจะให้สักคนหนึ่งมาทำที่นี่
you agree with
optimize.
that design. We didn't put subwoofers. We should put subwoofers to.
I was going to do after we optimize this one,
Ah.
if it's okay. Or in the morning, maybe.
No, tomorrow maybe fun part, bring speakers. Clear the
Yeah.
software part today maybe.
Can. But just make sure they understand this highs first. Okay. อยากจะให้คนหนึ่งมาทำที่นี่ เอามาเลย
To John.
So
Tomorrow we will bring some merchandise.
here we
like
have
and
a venue 100 meters deep, 80 meters wide, and we're going to optimize a big sound system for it. So
this
first
could
thing
be
is we're going to choose our quantity. เดี๋ยวจำนวนเพิ่มที่นี่ได้
Big Mountain Cat Expo will be similar sizing, 80 meters, 90, 100 meters depth. Open air. This is a free
This is
software.
free, yeah.
Yeah.
แล้วจะเปลี่ยนเป็น dBY ก่อน
We can send you the links if you want to download. We can send you the links of Ease.
แล้วเอานี่ง่ายไป
Ease is not
Auto
free.
shoot ไป
Ease
ก่อน
Focus is free, but Ease is acoustics. Ease Focus is
แล้วก็
2D free field, basically no direct sound, but free. Blueprint is free, but obviously it's no acoustic calculation. It's for direct sound, open air consideration.
Okay, so we have 100 meters. We got 18 boxes of line array, and we started with auto shoot. So we see it's loud up the front, and then quite linear, and then drops off at the back. From the front to the back is 12 dB. Does it pass? No. Auto shoot fucked up. So you always have to adjust a little bit. So usually for me, I work from the back to the front. So we fix our over here first, and then gradually go all the way back. So how can we get more volume at the back?
What to do to get, now we are looking at dBY, so it's 2K to 8K. What to do to bump up the volume back here? More narrow? Look at the PA.
It's already 0, 0.
And look at the angles, 0, 0, 0, 1, 1, 1. So it's quite narrow already. But look at the PA.
Correct.
Let's start to tilt it up a little bit. So now the PA is at minus 7.1 degree. You will think like,
One here, V.
do you check minus 7.1 degrees? Yes, we do. I will show you tomorrow. I will advance some topics, but
I've got a good slide on that. Oh.
it's okay. Doesn't matter. I will explain now. We have a laser that usually will come here. And then we connect it. And the light will go out. So we can know where is that will represent the axis of this box. So where we are shooting at. So,
Okay.
and also, not only that, it has an inclinometer. So it will tell us how many degrees is inclined, this thing. So it has laser, so it's kind of a pointer and inclinometer. So we can read this parameter here, and we can read if we are shooting at this distance with the
Okay.
first box. When we talk about first box, is the top one. We don't think this is the first
I
one.
think we
This is
can
the
change
last
this
one.
angle to
This is the
come
first one.
Up a little bit.
1,
So it'll
2,
be like-
3, 4.
Cool. Now we go to 1 degree up.
So we just changed 1 degree, but 1 degree over 100 meters. Wow, it changed a lot. Is okay or not okay?
Okay.
It's not okay because first of all, it's in red. Means we cannot read this system, so we need to do something with the angulation. But it's okay, we will get there.
It's gonna change. Okay, so the next problem is, the slope is quite nice, but at the front is too loud. You get too much of a peak at the front. So too loud in some area means we have to spread that energy out over a large area, not focus onto just that area. So we'd see, okay, the last box number 17 and 18 are kind of going to the same place. So we might need to change number 15, 16 and bring them kind of up a bit to make the slope a bit nicer. ก็ลองเปลี่ยนแถวๆ16 15
So we will
16 17
open it up
เปลี่ยนคือขึ้นไป
to avoid
ได้
to have
เพราะ
that
ว่า
much focalization of
ใช่
energy.
ขึ้น
So
ไป
now
คือ
they,
เลขน้อยลง
even though they are 777, but it has to
ก็
be
ต้องเป็นสัก6หรือ5อะไรวะเนี่ยลองไปเรื่อยๆก็ได้โอเค อันนี้คือเมื่อกี้คือไปไกลเกินแล้ว เหมือนไปโฟกัสอีกที่หนึ่งแล้ว พอเห็นไหมว่ามีดังแล้วเป่าค่อนข้างเร็วแล้วขึ้นอีกนิดนึงแล้วลงมา ก็เราต้องการให้มันสมูทตรงนั้น
this red dot means where is the axis of the selected box aiming at over the distance. So when he selects speaker number 17, it will flash in red and it will give you a dot where the axis exactly of that box is aiming. Why is that? Also because the line array boxes, we didn't say, but the dispersion in vertical is very narrow. So it's kind of like a laser thing, right? So it allows a certain degree of overlap between boxes for all the possible opening and closing angles, but it's kind of like a very focused sound on high frequencies.
ที่นี่น่าจะเพิ่มได้นิดนึง
So it's important to know where is the axis of each box. So also you can see the concentration of boxes that you have in a certain area. By just changing one point, we are changing the whole SPL across the venue.
So this is starting to get the shape we want. So starting to gradually drop down across the whole venue. Just a little bit over 6 dB, but I think that's, for an outdoor show, it's kind of okay.
So over how we say about the critical distance
Copy and
before,
neat
which
like
is the maximum distance where our system is working as a line array. So anyone can identify when this system stops working as a line array. So our maximum SPL, if you can put a cursor over this point, we will see the maximum SPL. So shit, I cannot fucking see it. 117, right?
Yeah.
So the maximum SPL is 117 dB. Can you go all the way until 114? 16, 15, and the HDMI is out.
Yeah.
We are audio engineers, sorry. Is it extender? But he's a video person, our sales manager, so he will fix the issues. I think it's extender. So we can identify.
It's Extron, not Kramer.
Where is extender?
In the wall over there.
Is extender or is here? It's from here.
From here to the wall over there.
But where is the problem from? I think it's from there.
Ah, okay.
Okay, Maleo. 114. Where? 115, right? I cannot fucking see anything. 115, a little bit more. Keep pointing down. A little bit more, 114.2, 114, something like that. So around 41 meters, this thing is behaving as a line array. So it's kind of like 3 dBs decay every time we double the distance. It's difficult to calculate when the system is in the air because it's not the same as we have it. We are measuring diagonal, so we need to consider that. But more or less around 40, 45 meters, we have a line array. Even more, right? Because it will have to keep decaying. So that will be our first 3 dBs. So it's around 41 meters. If you keep going until 111, keep going down. So check at 81 meters. 81, a little bit more to the left. 81, a little bit more to the left.
So this is going to be 111.
So we say here is at 40 meters is around 114.
94 meters.
At 94 meters, 111. So it's really working as a line array for the high frequencies all across the audience area. When a system is well designed, will behave like this. This will be A weight. So we are including mid and low frequencies down to, I think it's 125 hertz. The maximum is around 100 and what? I cannot see anything. 127. And then it will decay all the way down to 6 dBs or up to 90 dB. So it looks that the slope is following 3 dB pretty much every time you double the distance. But you cannot really check linear distance because the system, again, is in the air. So it's kind of like checking the diagonal.
However, if we then look at tonality.
Now we will compare dBy versus dBA to see if the high frequencies matches the mid and low frequencies and they follow the same decay, the same tonality. Do they? This first part kind of parallel, but in here we see it drops a little bit, where this is more like a constant drop. This one has like a little bit flat. So if eventually we pull this thing up, what will happen is both curves will cross, and we don't want both curves to be crossed. It means that we will have more high frequencies than mid-low frequencies. Therefore, sound will not be the same. The balance between mid and lows and highs will not be the same half of the place that the second half back of the venue. What to do? You should take a mic. They cannot hear you here. Don't perm high frequency. So you need to add a little bit more high frequency here to follow that kind of curve. So you can select, that should be around speaker number 8, 9, I think around. You can do two things. You can open up a little bit more the top boxes. Therefore, you will have a little bit more decay on the back. Yeah, can you deleteไป DBY ก่อนยึดอันนั้นเป็นออกเลยไป DBY ไป DBY. So you can also increase the decay here in the back by opening it up a little bit more. Or focusing more sound, more boxes in that area. Which you could do by closing maybe these ones a little bit, or opening up the upper ones. If you open up the upper ones, you lose in the back. If you close more the mid-low ones, you will spread this one a little bit more. So I would suggest you, this is quite a lot of energy here, I would suggest you please open it up, these boxes. Sorry, close them a little bit.
Take a video clip for PR
ได้เลยครับ
ขอบคุณครับ
ครับ So you see that we have this kind of, he did some kind of curve shape like this. We call it a smiley, like this. Meow. We don't want that kind of curve. It sounds weird because it's like, it's loud and then drops and then it goes up again. We don't want a roller coaster sound sort of thing. So we want like smooth decay, as much as smooth as we can. Question? Yes. This is dBY now. So it's from 2K average of octave, from 2K all the way up to 8K. So basically all your high frequencies. So you take a measurement center at 2K, 1 octave down, so it will be 1K basically, the limit, and all the way to 8K, basically is 1 octave up, so 16K, and you average all those. So basically it's all the high frequencies of the system. Mid-low? Mid-low should be once we change to A weighting. At this moment we are not looking at mid-low. This is mid-low now. This is mid-low now, which is dBA, this part here. So we need to do is both curves are parallel, as much parallel as possible, to avoid to have unbalanced sound. So that will mean that, for example, still he corrected ตัวนี้ดีขึ้นใช่ไหมครับเป็นมีเสียงมากกว่าใช่ไหมครับเป็นมี decay มากกว่า before it was like drop and then kind of flat But the DBA are low frequencies, and they are more like a point source. They keep decaying, they keep decaying, they keep decaying. But the high frequencies, as we have a lot of boxes, we can keep continuous SPL. So what he has to do is to allow the high frequencies to roll off together with the mid lows. You can do by either shooting out of the audience area. What I will do is take out some speakers too. No need to use 18 speakers for this venue. More is not better always. In this case, it's more complicated to manage that much speakers. We have done 100 meters with 12 speakers. 12 maybe perhaps too little, 15 speakers, enough for, but that happens when you know the brand of the system you are working with. แต่ตัวนี้ดีขึ้น If you add a little bit here, just a touch here, เพิ่มนิดหนึ่งตัวนี้ครับนิดเดียว only this area, touch up a little bit, and it will be perfect. So the box you are selecting, number 9, you can try to you see it changes a lot. That to me has to be a little bit higher up here. Touch up here. Okay, sorry. Delete อันเก่า and DBY ใหม่ Okay. So you had to bump up a little bit more here. So you were looking at DBA before. Okay. ประมาณนี้ Save it and then go to DBA again. Then we visualize DBA. ดีขึ้นไหมครับ Even if you overlap two curves, these ones, if we put both at the same distance, then you will have a little bit more high frequencies just at the very, very front, maybe a little bit more than mid-low frequencies. Maybe this part has to be a little bit high up, but it kind of follows the same curve, right? I will avoid this gap here. Maybe you see kind of like go down and then go up a little bit. We kind of don't want that. ใช่ อันนี้เป็นต้นลมมานิดนึงไป DBY นิดนึงอันนี้เป็นเยอะอยู่แล้วต้นลมมานิดนึงใช่ อันนั้นเป็น spread out นิดนึง This is very, very fine adjustment. But you see, just changing a little bit. If we don't get that right, nothing later on EQing, tuning, bring the system down, change the point, bring them up again, which is a pain in the ass. But it happens quite often because they don't give us the fucking rigging points we asked for. You see, the more speakers you have, the more you have to play with it to design the coverage. And don't forget, he still has no tension on the hoist, so he cannot rig the system. It's in red. So we need to play with the rigging later on. Maybe he's doing the whole design and he cannot rig it by any means too. It can happen that you put the bean from back, whatever, and there's no fucking way. So you had to scrap the whole thing and start from zero. แต่กันนี้เยอะแล้วขยากนะ We call this part is optimization. Optimization is to make it better, like very fine tweaks. ประมาณนี้ I mentioned before, some manufacturers will give you exactly, so the position 1 to 3 will indicate 1 degree, 2 degree, 3 degree. In the case of D&B, it's like that. In the case of Adamson, you can see the position 0 or position 1 is not the same as how many degrees between the boxes. So it tells you position 0 means an angle of minus 6.1 at that inclination. So at this moment, we have the vertical inclination of the system, or delta, is minus 6.1. So if the boxes has no inclination between them, it's minus 6.1. The moment we start to open up, so you can deduct that one pinpoint is changing 0.3 degree between the boxes. No, so it's quite accurate. You see, 1 is 0.3, change from there, 0.3, 0.3. So not in this system because this is S10, that's E15. So every point, so from 0 to 1 is 0.3 angles of difference between the boxes. So it's a kind of very... Hmm? 1 dB of summation for? I don't understand. Ah. On the aiming point between boxes. It's more straight. So now he put this. So usually the design principles, we will have one cluster, only one system. We design the angulation. Once we're happy with it, we put the stereo. We hopefully can decide the distance between clusters, and then we will run the simulation in color, the color mapping, which is already running. So calculation is 99% done. Yeah. So this is what I said to you. We put a very high resolution calculation, so it's taking fucking ages to do it. Any question while the computer is calculating? We're waiting for the beautiful colors to appear. Anytime soon. มีควันต่ำไหมครับ The next thing we will do is with the subwoofers. We put subwoofers and we will see how they behave. I think I made it. Yes. Sorry?
About the placement of the subwoofer, should it be like easier than the line view? Okay, so it's not. Yeah, I see your face now.
This is still a lot of misconception about this. You know, I think without looking down, okay, without any bad feelings or anything, but it's still like some people try to overdo in Thailand about the subwoofer. Now, like that you know how to do cardio and fire intercalate subwoofers doesn't mean that you have to do it. because it looks cool and it's great because you have more chances to fuck up, right? So we always stick to the basic. Okay, let's go for the basic. Center, all packed together. Electronic arc, if it's this kind of case. It sounds good. Okay, don't fucking touch it. It's already good. We know how these things should sound. We know what it can produce. So it's like, deal out. I don't want why. If we are not happy with it, we try to realign, tune, whatever. Okay, let's change the subwoofer. But as I say, that you have the option doesn't mean that you need to use the option all the time. Or as I say, overdo the subwoofer. Or, oh, I put the Endfire with, what was the combination that they were, the Italian guy did? I don't know how it's called. I don't even know how it's fucking called. Like a diamond configuration or something like that. So you just swap. So instead of Endfire, you do 1, 2, 3. You just zigzag. Offset and fire. Just to control, yeah, for what? So it's kind of like a black magic in Thailand. Something like, oh, you know, I did this and it sounds this fucking good now. Probably you are not aligning properly or something like that. So we usually try, the philosophy of many brands, especially, okay, I can tell you by experience the philosophy of this brand, the owner philosophy is try to have everything coming from, and I think many of the pioneers on professional audio, they try to have as much frequencies coming from a single source. So in the past, they were developing a double 18 inches line array. So it would go down to, I don't know, 30 hertz or something like that, but it was a fucking monster to rig. But maybe in that case, you don't need to use subwoofers. So therefore, you don't need to separate frequencies. There is one brand called Danley Sound Labs. They use like a huge speakers. So maybe one speaker would be, you know, the same as you stack like, you know, 8 of these. It's just one box. And it has the same components as this one has. And it gives you a fixed kind of sort of angulation. So it's like, okay, you don't need to use a subwoofer. All your frequencies are coming from the same point. So you don't need to separate subs. But you compromise. It's fucking heavy. If something broken, all your speaker, all your inventory has to be going to service. So this is kind of modular thing. It's not a miracle. It's not, perhaps acoustically, there are much better ways to do it. But if you think about talking especially only about live sound, maybe it makes sense of people that touring around, bringing the speakers in an arena, another arena. Okay, one box is fucked up. Okay, just bring it out, bring another one. When you have that kind of big point source or whatever cluster concept, it's a bit more delicate. You rely on less hardware. So it depends. Acoustically point of view, yes, it's better to have one thing. And are we done? Doing again, why? Didn't say. Calculation too slow. Has to restart. So you put too much resolution, the computer hangs. Questions? มีคนตามมาครับ Have questions? Everything clear? Tomorrow we will rig. I think after now we'll do the subwoofers, and then tomorrow we will rig. So we can start, you asked about subwoofer configuration, we can start with these 3 clusters and see how many chances to fuck it up we have. You say already left and right, we already mess up a lot just by separating them. Don't look up, don't look up, don't look up, forget it, forget it. Bring it down, pack them together, or put them all the way there, all the way there. Ooh. Okay, can you click on the red? The red point will be your loudest point, and the dark green will be your quietest point. But this is on the edge of the coverage of the system. So this system is around 70 or 80 degrees. So you can clearly see, you can target here, the yellow one, if you want. Yellow color. Siluan. Siluan dalan. 112, and then you can go. So each color is 1 dB. I mean, we can change the scale here, but usually each color means 1 dB less or 1 dB more. Steps of 1 dB. So the loudest point is 117, the quietest point is around 112. Ooh, 5 dBs on 100 meters. So jot. This is dBy. Let's go dBA. It's not optimized because the computer hang. But you get the idea. So usually you have the loudest point will be that. 128. You see you have more energy. We put in mid-low energy in it, so the SPL is higher. Then you can go all the way to yellow. 5 dBs too. So jot. So on 100 meters, we have a decay of 5 dBs only. Tomorrow. Tomorrow we cut your breath. Sanuk mai? Ngai. If it's in our training, we always bring our coffee machine and we will give in coffee espresso to everyone. So it's like, you're like, oh, more. Questions? Do you want to have a quick break? 5-10 minutes, stretch the legs? 10 past 4, and I'm about to leave because I have a meeting downtown, but I will come back tomorrow. You cannot. Subs? Do subs, maybe? Half an hour? Sorry? You say 10 to 4? Up to you. 10 to 4, right? I don't know. Ask them. เหนื่อยนะเยอะใช่ปะวันนี้ความรู้เยอะพูดเยอะ We spoke too much. Fine. We can do subs tomorrow. We can do subs today quickly. I need.
Something better to do than that, but if you want to play around with it, play while it's fresh, and then
tomorrow we will do subs then, subs on the simulation, and then we'll do that probably the first hour, maybe wrap up, come back to the original. Wow, that's a big banana. Then we'll go to the design of this room, and then we will start to do the sub configuration for here, and we'll start rigging. We will teach you about what are the things that we need to consider before rigging and during rigging and after rigging, and then we'll tune and align the system using the software, the magic pill. Did you put the slide of how much percentage at the end of?มีควันตามไหมครับอยากพักผ่อนใช่ปะไปเที่ยวwanna rest ไว้จะหยุด Okay. Tomorrow is gonna be more fun because it's less theory and more hands-on and listening. We can do some critical listening. I have an idea. If you have your reference song in a good format like wave or FLAC, please bring it over. So you have your favorite band, I don't remember the name, but you have it in a good digital format, bring it over and we will use it to listen to. Oh, well, you have any of your mixing project that you already master and mix, bring it over. We will listen on the... We can, yeah, we can also mix. You can do the multi-track playback directly here. We have the Dante card. We have the Dante card here, so you can interface and you can mix live if you want. If you feel like, can do. So you use a big monitor system, big reference monitor for mixing. But if you have your reference track, your reference music, in a high quality format, don't bring me MP3s, please. 96K up. So choose 1-2 songs that you like, that you know sounds good, of your projects, bring it and then we'll test. And then we will do the critical listening. So we'll teach you how to, because at the end of the day, yeah, we have software, we have a lot of tools to make sure that it's all okay, but this job is a lot of using this. In our part, it's not from the artistic point of view. In our part, it's from the, we always say we are the people who will tune the piano. So we make sure the piano, when you press La, is 440 hertz. That's our job. We tune it to make sure the piano is producing that note accurately. The artistic part is up to the front of house and the band. But we make sure the instrument is properly tuned. So that's our job. So we will teach you how we do critical listening without any artistic. So differentiate instruments, going out of the mix, certain passage of the music that are reproduced properly, and that kind of things. So if you have your own tracks, please, it will be good. Because tomorrow we can let them evaluate whether we can maybe do 2-3 configurations on subwoofers, left, right, center, and fire, double and fire. Yeah, we can do double and fire. So it will be 1, 2, 3 cluster. We have space. We can put individuals. We can tell you the difference between cluster them and put it on the ground too. We have more ground coupling. Oh, we can do that too. มันสนุกนะ Okay? Thank you ครับขอบคุณครับ Simon อยู่ใกล้ๆจริงๆแล้ว this morning we were on time but he missed the exit of the highway and he's like oh no and then and he got the exit of the highway and the exit here. So instead of going in Salaya, when we go to Salaya, instead of going to the left, but the problem is I come here, my wife lives around here, so I come here, I don't know, 1,000 times, you know. And I said to him, yeah, this one. Oh no, shit. Thank you ครับขอบคุณครับ
C1, the control software for DMB?
Raycalc?
Not a Raycalc, but the once you're controlling the amps.
R1.
R1.
It's free to look.
Yeah, I'll grab it tonight. I think I have it.
To mess around with that? No, don't touch it.
I just want to mute it. Just to mute that and the subs.
But we can send from here to the mixer, right?
Yeah, but I don't